Yeah, thank you for the introduction. I hope you can see the full screen of my presentation, not my presentation view.
Yes, we can see the full screen.
Okay,
All fine.
thank you. Yeah, good morning to everyone. Apologies that I couldn't be there in person. Thank you so much again for the introduction. And I'm Sathya. As introduced, I work as a computational scientist with the Science and Technology Facilities Council in the United Kingdom. Thank you again for inviting me to share my experience for adopting NOMAD Oasis for supporting our community's data management needs. My FAIR database project, which is the main subject of my talk today, is jointly funded by the Physical Sciences Data Infrastructure, who are also a part of STFC, and the Computational Science Center for Research Communities, who are the source through which we receive funding from the funding bodies. And the main benefactor of the database are the solid state NMR community who are represented by the CCPNC. And I'm hoping to share with you today a bit about who the CCPNC are and our main motivation for why our database comes about, what's stored in the database, and why we are moving to the NOMAD Oasis as a solution, and share with you about the development experience. And since our Oasis is not a deployed solution yet, it's still much of a work in progress. Mostly it'll be presentation on my part, and I'm hopefully if time permits in the end, show you a quick demo of how things are coming along. And while I share all the things that we have gained from NOMAD, I will also share the current works in progresses and potentially any challenges that I'm facing along the way, so that that will lead me to future plans on how we aim to solve the problems and questions which can go two ways, I think. My questions to the NOMAD team and any questions from the audience. So to quickly introduce who the CCPNC are, since I said they are the main benefactors of the database, they are a computational project initiative. The UK has many CCPs like this, and this particular CCP is dedicated to the NMR crystallography, and it comprises of both experimental and modeling computational researchers who are based both in academic institutions all over the United Kingdom, and a lot of pharmaceutical industrial partners who collaborate with the academic partners to generate a lot of research. The core computational effort for developing the computational NMR software and the Python libraries and the visualization tools, etc., are provided by software engineers from the STFC, such as myself. And to tell you a bit about what's in the database, we store outputs from several DFT calculations from several DFT codes, such as CASTEP, Quantum Espresso, WASP, and many other DFT codes. There are at least 10 DFT codes that can compute NMR parameters and output them, but all of them in their own respective file formats, which when you try to have a unified database to store them in a single place, can be a little bit of a problem when the rest of the community wants to benefit from your research and they don't use the same softwares as you. And that is why the Magres format, a simple text-based file format, was developed by the CCPNC in 2014 as a standardized format to store information from all DFT codes in a single standardized data format. Maybe the text on the screen is not big enough for everyone to see, but this is just a sample Magres file, and the main highlights is that it aims to be self-sufficient in all the information from computations that it wants to store, such as the calculation metadata block, which contains information about the DFT code, the code version, and other simulation conditions that were set for running the computation. The crystal structure information is packed away into the atoms block, which contains the lattice and the atomic positions plus any symmetry information that can be packed in. It aims to contain the same amount of information as CIF files and any other known crystal file formats such as X, Y, Z, and so on. But I think CIF may contain a lot more information. Magres loses a bit, but I think it is quite similar to XYZ format. And there is the main Magres data block, which is where all the computed NMR parameters are stored. And all of these parameters are stored for the individual atomic sites within a crystal structure. And to give you an overview of the general size of the database, it's a modest database with close to about 6,000 entries with a split of 60-40% between organic and inorganic materials. And most of our organic entries are linked to unique CSD ref codes from where the reference structures have been obtained for the computations. Our main motivation for moving to NOMAD as a database was for achieving FAIR compliance. As you can imagine, to start off as a simple database initiative for a niche scientific community, it's not straightforward and easy to achieve all aspects of FAIR straight away. There are challenges that present themselves. Mainly, the main challenges for us were not the findability and accessibility aspects, but in terms of interoperability, though the Magres format aims to be interoperable by unifying DFT codes, we don't have, for example, an Optimate interface, which will let us exchange our data with other databases, such as NOMAD. And the reproducibility, as we saw from the Magres example, it does aim to be self-sufficient and pack a lot of information in it at the Magres file format, but it comes with its own limitations. It does lose some vital information. The advantage we gain from storing only the Magres files from simulation in our database is having a very lightweight database, but the disadvantage is that there are much more information packed inside the simulation output files, plus also any geometry optimization information about operations that were performed to relax the crystal structures beforehand are all lost when you try to reproduce. All the information is not completely available. But the NOMAD's offer of a unified data model, standardized parsers, and the potential framework where we could link workflows between several DFT codes and directly to Magres gave us a promise to solve that problem for us. And it also aligns us with FAIRmat and the wider material science community, making our data more visible and hopefully more reusable for the wider NMR users who use central NOMAD platform as well. And the first steps we took in terms of our development was to define the schema and parser, which is the main starting point for any database. Our initial contact with NOMAD was just to ask for, could you add our data quantities to your core data model, and please add Magres parsing support to your central parsers so that we could directly adopt your Oasis solution. But then I think we contacted NOMAD at a right point in time, because we were given the opportunity to develop all our packages ourselves, because instead of the core data model now, the collaborators have the opportunity to write their own plugins, and we really like that opportunity. We were recommended the use of NOMAD infrastructure by the Physical Sciences Data Infrastructure, who had already scoped out FAIR database technologies, and NOMAD ticked quite a lot of boxes and were ideal for all the goals that we wanted to achieve for our database in our journey to FAIR data. We like I said, we got the opportunity to develop our NMR schema as a standalone package, which was not possible. We had developed a simple schema just to extract data from Magres file formats and deposit in our database. But now we had the opportunity to write a centralized schema for NMR, which could not only act as a beneficial reference point for the CCPNC community for all NMR users of NOMAD, and I think we are contributing that back to NOMAD, and hopefully that will be useful for everyone. In our database, we provide support only for magnetic shielding and electric field gradient quantities, although the Magres file format itself has the potential to store a far more quantities that can be computed by DFT codes. And in the NMR schema, we had the opportunity to expand support for adding in these quantities, plus a lot of other quantities that are derived from these raw tensor quantities that are calculated originally by the DFT codes. Because it's not the raw tensors alone that people want to search for, it's for quantities that are calculable from the tensors themselves. And through our collaboration with NOMAD, we got collaboration to Exact Lab as well. And I think hopefully some Exact Lab researchers may also be present there. So shout out to them, especially to Cecilia from Exact Lab and Michele from University of Trieste, who collaborated with us, and their conversations were in related to making improvements to quantum espresso parsers themselves. And that conversation led to Magres, and they contributed some vital quantities to our NMR schema for the electron paramagnetic resonance as well. And this benefits not just the NMR community, but our brother community of muon research as well. We then developed from the schema the Magres parser, of course, whose base functionality was to extend from the NMR schema, extract quantities from the Magres file for storing in the database. This is a plugin that has been developed using the new data model. I don't know, maybe I think we are one of the first collaborators of NOMAD who may be developing our plugins using the new data model as they transition from the old data models to new. So I think we benefit from that. And we benefited a lot, as I will mention a bit later, from the newer version of updates to the NOMAD simulations package. But I really appreciate that the parsers on NOMAD can be more than just that to extract quantities from the schema. Beyond the core schema and parser that we developed, which could be used by Central NOMAD as well, we had the opportunity to extend it and write our own customizations for our Oasis, which is more relevant to the scientific uses of CCPNC. We needed to get something more out of the schema and parsers to support migration from our old database to the new NOMAD infrastructure. And we wanted solutions that would not keep bulking up the plugins that we were writing, but something a bit more elegant. And we were presented with challenges in parsing data. We not only wanted to write a simple central schema plus parser that will deal with all the legacy data that are migrated from the old database, but also will support similarly all the new deposits that our users will make, provide almost the same functionalities that we could still provide from the old database, but also avail all the extra functionalities that NOMAD can offer. We had to divide the problem into, and we split it up. For legacy data parsing, we needed to capture additional metadata such as crystal structure, notes that the users may enter at the time of deposit that are not found in the raw files themselves. And they have additional notes from their research about the individual structure files that they upload themselves, about and maybe a base original reference structure and what was varied from the structure, many structural variations and polymorphic forms of the structures, those information, and on top of the basic chemical naming that can be assigned using formulas, any free text chemical names that users can enter, which can be common names or IUPAC assigned names. Plus, we use ORCID for our authentication system. So ORCID IDs of users to be used with the records as well. All that needed to be migrated. and we had all these stored in JSON file formats. And so NOMAD developers offered us a simple solution to add JSON file recognition to capture and deposit these quantities and develop a customization extension to our parser. And we also then raised a question of, okay, besides JSON support, how do we deal with future uploads when users want, we collect information, the metadata information from our users a bit differently in that if they upload data in bulk, we ask them to fill in a CSV file that contains the individual file names that they are depositing and the several columns that contain the accompanying metadata. These are mainly users who generate, like I mentioned, original structures and variations of structures and publish these results in journals, and they want to deposit their publication datasets. And sometimes machine learning trained datasets such as ShiftML, we want to acquire those and deposit in our database as well. And in these cases, we have to fill in a CSV file with individual details for all the files in our bulk upload and upload them. And again, this was quite simple because once you add a JSON file recognition, adding a CSV file recognition, and attributing the metadata to the individual files is quite similar. But sometimes the NMR researchers can also often study just single materials, deposit single Magres files at a time. And for these uploads, we wanted something less clunky. We don't want to ask them to fill in a CSV file just for the sake of a single Magres file. And it was quite tricky because we couldn't design our own deposit form as like a JavaScript and add it. But I think Nomad had a built-in solution for this as well. And I benefited quite a lot from discussions with the community besides the developers. And Joe and Pepe, I think, suggested the electronic lab notebooks for these as a solution. And it was quite straightforward. When I deposit a Magres file, I could just make my parser to check for accompanying metadata files, either in a JSON or CSV format. And if they were absent, simply just create an electronic lab notebook and prompt the user to enter all the metadata that needed to. And once this is saved, it automatically gets ingested with the record, which is all quite straightforward and nice. And then once we developed all these underlying bricks, the building blocks of to run our database, now it came time to develop customize the GUI options to present the NMR app for our community. The NMR app that we have designed for our CCPNC Oasis is quite sleek, actually, thanks to the inbuilt filtering menus and widgets that support data filtering. Most Nomad users who have customized an Oasis for their database know how these features work, so I don't have to spend too much time talking about how those work. That's not the point. I just wanted to take the opportunity to highlight a challenge that I faced when designing the apps. I did not have trouble making the custom CCPNC schema data searchable via the filtered menus and widgets, but for example, when using the periodic table widget, the trouble I had was getting the element blocks to talk to the newer data model. For example, the new system, the crystal structure system, when it's parsed, it's stored a certain way. They are not called atom sites anymore. I think they are called atom states. They're called particle states now. So the challenge I faced was that these widgets, since they are programmed and built within the UI element of Nomad Lab, we had to still find a way to populate our database entries both in the new data model and also populate the old data model, such as the results section and the run section so far in the old data model, so that we could get the widgets to work. I think one more challenge I could mention similarly was like the nice crystal structure and all the cool information that gets pulled into one place in the overview page of each entry. This we could make work only as long as I filled in the topology section within the results. But I think this is all understandable as this is just an interim solution as Nomad is transitioning from the old data model to the new, and it takes time to develop all parts of the entire package to work in unison. So this is all still welcome. We have a nice functioning Oasis, and I wanted to stop at this point, give a quick shout out to Esma from the Nomad team, because when we developed certain aspects of the new data model, we wanted to make some customizations to some entities. We wanted to store it a particular way. As I said, the parameters in Magris are calculated per atomic site, and we wanted to make the site descriptions as descriptive as possible. So we wanted some customizations, and Esma worked with the rest of the team to make these customizations as fast as she could. So shout out. And also, thank you to Misha and Mika and Edgar from the Helmholtz Center for discussions that we had about um, Wala notebooks that I wanted to implement, which in the end for us ended up being too much of a sophisticated solution. But without spending too much time talking, I want to quickly show our Oasis what it looks like. From the welcome page, I have customized our system to work with ORCID authentication since our community prefers it. Of course, I'm still keeping the central login for administrative purposes. And the ORCID login is quite straightforward. If I'm pre-logged into ORCID, it's almost invisible. If I'm not, it just takes me to the ORCID page. I log in there and ORCID sends information back to Nomad, and my user information is validated. I wanted to quickly show you the app that we are building and all the records. Like, this is not the complete account of all the records. This is still in the process of migration. But this is what my customization looks like, because our users prefer to search for materials quickly by material name, and our internal Magris database IDs and author information, we have made those visible in the filters straight away. And of course, the widget I've made available periodic table for users to filter by material. And these materials are all, one interesting thing was that these entities such as the material name and the DFT code that we used to calculate, etc., these were all part of the custom schema rather than the new Magris Nomad's data model. So these custom quantities, they could be easily linked to the parser, the filter menus, for example. But since some of the core parameters, the NMR parameters, they are housed within the output section within the new data model, I think it's quite challenging for us to link those, but we are working to find a solution. Like at the moment, like it's quite easy to search for just a calculable version and get a nice distribution on which version of CASTEP that users have prefer to use the most, maybe use some chemical formula, filter entries by the number of elements that I want in a material. Okay, change the filters. And yeah, okay, Clementine Mostin is the author that has made most contributions with the CASTEP simulation, so I could search for those. I can even filter those by specific database, and I can keep filtering down by specific ref codes for particular materials that I'm interested in. And publication DOIs, users can search by specific DOIs from journals to, since we are storing that information in our legacy data that's available. And though Nomad itself permits all records to have a CC BY license, we have just migrated. We are not trampling with how Nomad does things. We are simply retaining the license information that we have migrated from the old database, so that users, if they want to look for records by a certain license information, they can. This does not affect how Nomad does things. And similarly, DFT functionals can be used for search. I wanted to quickly show inside the database as well. This is the new appearance of the new data model where the outputs, such as the core NMR parameters that we calculate and the individual atomic sites can be accessed. And these are the raw tensors, and all the parameters that can be calculated that we defined in the schema are all in one place, and users can look for individual atomic sites to look for this information. And of course, the model method, the DFT calculation information, and the system information, the unit cell information, particle states. These permits us to define the individual atomic sites individually and define the atomic site labels for outputs. And CCPNC metadata is the section, the custom addition that we made, where we are porting all the information from the old database to retain and assist in the latest information searchability on the new database. I wanted to also show that, okay, as I mentioned for, yeah, am I running over time?
Yeah, so maybe
yeah, okay.
Conclude.
Yeah. Sorry, yeah. The one thing I wanted to mention was, as you can see in the outputs, since we want to search not only for specific elements, but also material properties for particular elements within materials, this becomes an area of nested search. So I think having that nested search from the filter menus for custom quantities becomes challenging for us. So that's one thing I wanted to leave with NOMAD, just to ask maybe if support will be provided in the future for that. But of course, thank you. I don't think I'm leaving much time for questions. I'm sorry for that, but you can find me on Discord and contact me via email as well if you have more questions. Thank you. Thank you so much.